Okay, in this video, our last video for the 7-4 homework, we're going to go over questions 7 through 10. So a couple important pieces of information to highlight here. One, we have this initial condition when t equals 0, there are 10 grams, and we have this differential equation here. So we want to write the tangent line at t equals 0, line tangent to the graph at t equals 0. So we know we always just default to thinking about point slope form there, and so that's nice because we have a point. There's 10 grams, y minus 10 is equal to, and this next one is going to be the slope. I'm just going to leave that as m for just a moment, t minus 0. I apologize, there was a typo originally, depending on when you access this for the first time. This was an X, and hopefully that didn't throw too many people off. If that threw you off, I apologize. So now we have to think about, well, what is this m value here? Well, m we know is given by the slope, and the slope is negative 0.02y squared. And we have the y value of 10, so negative 0.02 times 10 squared, which is just negative 2. So that's going to be my slope value here. So we'll just take that, plug it in there, and that'll be your equation. I think maybe another thing that threw people off, again, I apologize if the typo threw you off, but maybe we were thrown off. We thought we had to do something extra just because this derivative is in terms of a y squared rather than an x or a t squared, but it doesn't matter. It's just what I have to plug in. So I'm going to plug in the 10 because that's the y there. Next question asked you to use that tangent line to approximate the amount of substance remaining at t equals 2 seconds. So our tangent line again was y minus 10 is equal to negative 2 times x minus 0. And to approximate the amount when x equals 2, sorry, not x, did it again there. Sorry, I just default to x. Get rid of that. This should be t minus 0. Hopefully that didn't throw you off. So plug in 2 for t, and you should get y equals 6. So y is going to equal negative 2 times 2 plus 10, which is 6. And that's an approximation because you're approximating the original function with the tangent line. Okay, so that's number 8. Number 9, if we can find it down here. So using that same differential equation as we've been working with, we want to look at this drop-down question here about this given graph. And so your options for this first blank are yes or no, and then for the second one, the graph of f could or could not resemble the graph above. And our reasons are because the first derivative, dy dt, is either positive or negative for all values of either x or y in the first quadrant, so the graph will always be increasing or decreasing. So if we think about this, think about the because, well, the dy dt, again, that we're working with here, dy dt is equal to negative 0.02y squared. So as long as y is in the first quadrant, and in fact for any value of y, because you're squaring it, this piece of my derivative is always going to be positive. So you take a positive times a negative, you're always going to get a negative. So that means no the graph of f could not resemble the graph above because the derivative is negative for all values of y in the first quadrant. So the graph will always be decreasing. Because basically this derivative, the way that we've written it here, does not depend on x. So as long as I plug in a positive y, which the first quadrant will always have a positive y, the derivative will spit out a negative, which means that the graph always has to be decreasing. This little chunk here is not allowed. So we can't have that. So this does not work. Okay. Last question. So this is the one that I think many of us had the most difficult time with, and I really think it's just reading this carefully that is so important for this one. So the amount of substance is changing at a increasing or decreasing rate. So we're not saying is the function increasing or decreasing. We're saying is the amount it's changing at. It's changing at a increasing rate. Not the function is increasing, not the function is decreasing, but its rate is increasing or decreasing. So right away, that tells me that this second blank has to be the second derivative. Second derivative. Even if I don't know anything about the first derivative or the second derivative of this particular question, I know just by reading this question, we're changing at an increasing or decreasing rate. Is the rate increasing or decreasing? Not is the function increasing or decreasing, but is the rate increasing or decreasing? It's the second derivative that tells me if the rate is increasing or decreasing. And so now I just need to decide, okay, well, what is it? What is the second derivative? So let's start by thinking about what's the first derivative, and then we just take the derivative of that. So same derivative we've been using. dy dt is equal to negative 0.02 y squared. We'll take the derivative of that. Hopefully that's easy enough. I need the second derivative with respect to t both times. So power rule here. So negative 0.04 y, but because this is a y, and I'm taking its derivative, and y is my output variable, not my input, I'm taking the derivative with respect to t, I have to do implicit differentiation. So times dy dt. Well, what's dy dt? It's this. So this equals negative 0.04 y times negative 0.02 y squared. Simplify that, and we get positive 0.08 y cubed. So, is that value, the second derivative, going to be positive or negative in wherever this question is asking about? So as long as y, the sign of my second derivative is only going to depend on y, because my second derivative only has a y in it. And as long as y is positive, when you cube it, it will be positive. This number is positive. So we're not doing anything fancy to y, like taking a sine or a cosine, or we don't have a parabola that's going to change back and forth between positives and negatives. This cubic simply is going to be positive if y is positive. This is not going to change that. So the second derivative is going to be positive for all positive values of y. And so that if the second derivative is positive, then my rate is increasing, because the second derivative is just the rate of change of the first derivative, which is the rate. So a positive second derivative means that the first derivative is increasing, and the first derivative is the rate. So a tricky question for a couple reasons. One, did you read this correctly? Did you read this first part? It's changing at an increasing rate. Right away that tells me second derivative, and changing at a blank rate, either increasing or decreasing. That's second derivative that I'm talking about. Then did you take the second derivative correctly? Make sure you have this correct second derivative here. And then that should allow you to fill this in correctly. All right, so that's questions 7 through 10. Again, please make sure that you go back after you've watched these and update your answers. I want you to get full credit for that. Just like regular homework, you should get full credit for having done it and checked your answers and asked questions. In this case, you're just checking your answers via the video, and hopefully I answer all your questions on the video. If there's something you're still confused about from the video, send me a message. All right.